Welcome back. We're finishing up chapter 3. This is where factoring gets real good. So let's get started. In the next 3 sections, we're going to be focusing on factoring expressions in this form here. So that's ax squared plus bx plus c, where a, b, and c are going to be actual numbers and x is our variable. Expressions in this form are called quadratic trinomials. They're called quadratic because there's an x squared. The largest exponent is a 2. And they're called trinomials because there are 3 terms in total. I'm going to cover 4 different techniques in this video. I don't need you to be good at all 4 of these. So if you're really a master at one of these techniques, that's pretty much good enough for me. I would like you to at least take a look at all of them so that you can decide for yourself which ones you think are the best for you as a learner. And I don't know, maybe you'll find something interesting that you've never seen before here. I won't do every single problem using all 4 techniques, of course, but we will at least see examples of all 4 of them. And you can use any of these techniques for any of the problems that you see to verify that the answer was correct. Okay, so remember this right here, ax squared plus bx plus c, because we're going to confuse you now and change the letters on the next screen because we can use any symbols we want in math. It's the structure that matters. So now we have, check this out, 1x squared plus px plus q. So the a value from the previous page is just 1. The b value from the previous page is p, and the c value from the previous page is q. This is an easy type of factoring problem. It's when the leading coefficient is 1. So the coefficient of x squared, when that is 1, it's going to be easy for us to factor. And it's always going to factor into something that looks like this here, where it's x plus or minus one number times x plus or minus a second number, which on this screen we're calling them a and b. What's important to note is that when I take a plus b, I'm going to get p. And when I take a times b, we're going to get q. Let's see a simple example of this. So if we wanted to factor this, I'd be thinking about, what 2 numbers, when I add them up, gives me 7, but when I multiply them together, gets me 10. And those numbers are 2 and 5. And in this case, those weren't too hard to come up with. In general, however, I would encourage you to start by thinking about the multiplication because there's only going to be a few different integer pairs that will multiply to 10, right? It's just its factors, so 1 and 10 or 2 and 5. But there are really an infinite number of integer pairs which would add up to 7 because we got like 1 and 6, 2 and 5, 3 and 4, 0 and 7, -1 and 8, -2 and 9, and so on. So start with the multiplication first, and then see which one of those pairs adds up to 7. So 1 plus 10 is 11, but 2 plus 5 is 7. So that's our winner. And so we can factor x squared plus 7x plus 10, and that's equal to x plus 2 times x plus 5. And of course, we could check our work by multiplying these two together, combining like terms. We saw this in the previous video as well, and we should get x squared plus 7x plus 10. So for the first few problems that we look at, this is the plan. We have 1x squared in the front, and we're just going to find 2 numbers that add up to the coefficient of x and multiply to the constant value. So in letter A, 12. I'm thinking, what are the factors of 12? Well, could be 1 and 12, could be 2 and 6, could be 3 and 4. Do any of those pairs add up to -7? Well, no, but 3 and 4 comes close. If I add 3 and 4, I get +7 rather than -7. Hey, guess what? If I make them -3 and -4, they still multiply to 12, and now they add up to -7. So those are my numbers. That factors into x minus 4 times x minus 3. Same thing on the right. I need 2 numbers that multiply to -15. There are 4 different pairs that could do that. Let's actually list them all out with all the negatives this time. So 1, negative 15, negative 115, 3, negative 5, negative 3, 5. Which one of those 4 adds up to negative 2? It's going to be 3 and negative 5. So those are going to be the 2 numbers that we have as our factors. So far this is not too challenging. But we could also have to remove a common factor, and this should always be the first thing that we think about when we factor anything, is check, is there a common factor? And in this first problem, yes. 3, 6, and 72 are all divisible by 3. So that's the first thing I want to do is just take that out. And now I look at what's left behind. X squared plus 2x minus 24. Can we come up with 2 numbers that add up to 2 and multiply to negative 24? 24 has the h factors at right. Now, one of those in each pair is going to have to be negative if I want to get a product of negative 24, right? So just mentally play around with it and figure out where could you put that negative in order to get a sum of positive 2. We're going to get positive 2 if we add up negative 4 and positive 6. So those will be my factors, and this is my final answer. 3 times x plus 6 times x minus 4. Same thing with the one at the right. In this case, when we rearrange it, because we want to put the x squared term first, we notice that it's negative x squared now. I don't want to deal with a negative there. That kind of makes things a little more confusing, so let's just factor out a negative from everything. That means we're going to change the sign of all 3 of the values here. So now it's negative 1 times x squared minus 4x minus 77. And again, we're going to try to figure out 2 numbers now that add up to negative 4, but multiply to negative 77. 77 is a big number, but it really has no factors except for 1, 7, 11, and 77. So we can come up with a pair pretty quickly. So 2 slides back, we had this problem in green, and we've already got the answer there. Now I want to look at this in terms of the grouping method, because we saw that in the previous video. The idea here is we need to take this middle term, negative 7x, and we need to split it up into 2 separate values. That way we have 2 pairs of terms that we can factor separately. So the correct answer here is to separate it into minus 4x and minus another 3x. Now clearly that's mathematically correct. Negative 7 is the same as minus 4 minus 3. And the reason this works for grouping is that now these first 2 can be written as x times x minus 4. And then if I take out a negative 3 from each of those, so I've got a minus 3, what's left over is going to be x minus 4. Careful with those negative signs. Check, negative 3 times negative 4 is positive 12, so that's correct. And now you can see those 2 are repeated. So I've got x minus 4, and what's left over is x, and then minus 3. So I've got the same answer as before. We can even switch the order of the 2 terms that we split the middle into. But from here, we're still going to get the same answer. But this would not have worked had we split it up into, say, minus 1x and minus 6x. This actually looks promising at first, because the first pair has an x in common, so it's x out and then x minus 1 left behind. And then 6 and 12, they clearly have a common factor. We could take out, say, a minus 6, but that'll leave us with x minus 2. Now there's nothing to factor out. Nothing's been grouped appropriately. So that doesn't help us. So how do we choose what to separate the middle term into? Well, whatever we're going to break this into, whatever the coefficients are going to be, they have to, guess what, multiply to that last number and add up to that number. So we had, in our correct work, it was minus 3x and minus 4x. And minus 3 times minus 4 is 12, and we add them up, it's negative 7. It was a coincidence in this case that the 2 coefficients here were the exact same numbers as what we should have gotten there. That's not always going to be the case. So now we are into section F, and we're going to look at problems where the leading coefficient is not 1, but also we do not have a common factor that we can pull out as we saw in the previous ones. And first we'll look at it using the grouping method again. So the change we need to make now is that we're going to find, when we're breaking up that middle term, b, we're going to break it up into two numbers who add up to b, so that part hasn't changed, but whose product is now not just the last number, but the last number times the first number. And when you think about that, actually, that's the exact same thing as what we had here. It's just that the first number was 1. 12 times 1, of course, is 12, yeah? So really, this is no different. We just have to think a little bit harder about it. All right, so we're finding two numbers. The product is a times c, the sum is b, and then we can continue with grouping just like before. So first example, we're going to look for two numbers that multiply to 30, so that's 3 times 10, but which add up to 17. Okay, so just like before, I would start with the product first. So when I think of 30, 1 and 30, no, 2 and 15. Oh yeah, 2 plus 15 is 17. So we can group right here. We can separate the 17 into 2 plus 15. And now we're ready to factor by grouping. What do these pairs have in common? The first pair has an x, the second one has a 5, and now I have a 3x plus 2 in both of them, and we're done. And just like before, we could have switched these two, and it would have been fine. Another example over there on the right, we need two numbers that multiply to negative 60, but which add up to negative 11. So I'm thinking about 60, that's 1 and 60, 2 and 30, 3 and 20, 4 and 15. Oh, 4 and 15 are 11 apart from each other. I need one of them to be negative for the product to be negative. I need 15 to be negative in order for the sum to be negative. So it'll be 4 and negative 15. Here we go. Negative 11 has been changed to minus 15 plus 4. And now we just group like before. Here's another one that has a common factor we want to remove first. It's easier if we have a leading coefficient that's positive. So in this case, they just pulled out the negative first. And then we're looking for two numbers that multiply to negative 30, but add up to positive 7. And that's going to be 10 and negative 3. And hopefully you can follow the rest of this without me saying anything. If you're not a fan of the grouping, going back to the idea of intelligent guess and check here, and this is the problem from the previous screen, so I already know what the answer is, but let's pretend we don't. So I want to factor the expression at the left. The way that I might approach something like this is to say, well, if I want 5x squared, that means one of these is going to have to be just 1x, and the other one's going to have to be 5x. And then if I want a minus 6 at the end, I know that these other two numbers are going to have to be either 1 and negative 6, or negative 1 and 6, or 2 and negative 3, or negative 3 and 2. And then I can either write them in and see, or I can mentally just try various pairs in those blanks until I find the one that works, which is, as we know, going to be plus 2 and minus 3. This is another problem from a few screens back. Again, I have the answer already on screen, but how would I come up with that in this case? This one's a little bit harder because 6x squared, we could get the 6 from 1 and 6 or 2 and 3. And likewise, we have a lot of different possible values for what could go in the blue blanks as well. So you just gotta try them out until you get lucky. As you do more and more of these, you'll start to get the feel for it. You'll start to, I don't know, you'll just get a sense for what values work. And in this case, as we see again, it's going to be the 2 and the 3. And then it's going to be the negative 5 and the 2. But of course, we have to make sure that they're paired up in the appropriate order. So now I'm going to give you a kind of a geometrical approach for this. And this is what I call the X rectangle method. And that is not at all an official term. I literally came up with that name like 5 minutes before shooting this video because I just wanted to call it something. All right, ready? I got my x, I got my rectangle. Let's do this thing. I'm going to take my middle term, the entire thing. I'm even going to bring the x's along for the ride this time. Throw it down here. And I'm going to take the product of the entire first term and the entire last term. So that's negative 60x squared right there. And now I want to find out two terms that add up to negative 11x and that multiply to negative 60x squared. We already discussed this on a previous page. It's going to be negative 15x and 4x. The only thing different now is I'm including the x's. Before we were just thinking about the numbers. When you feel comfortable with that, we're ready to move on to the rectangle. I'm going to take my entire first term. I'm going to put it in any box that I want. It really doesn't matter. I always like to put it in the lower left-hand corner, but whatever. I'm now going to take my last term, negative 10. That's got to go in the opposite corner. So once I choose where my first term goes, my last term automatically has to go in the corner across from it. And in those other two boxes, I'm going to put these two numbers. It doesn't matter which one goes where, just one in each. And now I'm going to look at each row and each column, and I'm going to find out what do they have as their common factor. So if I look at the first row, both of those terms have in common a negative 5. But look at the second row. Both of those have in common a 2 and an x. If I look at the first column, those both have in common a 3 and an x. And if I look at the second column, they both have in common a 2. Do you remember what the answer was on the previous page? It was 3x plus 2 multiplied by 2x minus 5. And I said this is about area because if I imagined this length here to be 3x and this length to be 2x, then the area of this rectangle would be 6x squared. And if this was 2 multiplied by 2x, then that area would be 4x squared. 2 times negative 5, I don't know what it means to have a negative area, but whatever, that would be negative 10. And then 3x minus 5 is going to be our negative 15x. And we know that if we add up all 4 of those smaller areas, we should get the grand total area, right? Well, those 4 areas put together are 6x squared minus 15x plus 4x minus 10, and that should equal the whole big area, which is going to be 3x plus 2 times 2x minus 5. And if we just put those two together, we get the original question and its factored answer. The x rectangle method takes some time to do. You got a lot of stuff to draw in, but I personally love this method. It's what I tend to do when I'm factoring challenging quadratics. It just makes sense to me. I'm a visual person, so I'm a fan. But I also think that a lot of you watching this are probably just better factorers than I am, and that is not me being modest. I've never been like a super fast factor person. So if you're really good at this stuff, then you're probably just going to do it in your head using the guess and check, or maybe even the grouping method. All right, section G, like I said, there's actually nothing in it. It's just mixed problems, but they do have a flow chart, which was okay, but I didn't love it, so I've made my own version of it here. Our first step is always going to be to look for a common factor. If we can pull out a common factor, then all the other numbers are going to become smaller and easier for our feeble human brains to work with. If you don't see a common factor, you can still use the other methods. It's just going to be harder, so be on the lookout for those. After we've gotten past that, we always want to look for the shortcuts. Those were referenced in the last video. I've written them out to the right. If we spot those, then our lives become much, much easier. Even if we don't see them, we can still approach the problem using the other methods that were referenced in this video. And as with anything, the more that you practice these, the faster you will get at them, and the less you'll have to write down, and the more you can just do them in your head. All right, so thank you for sticking this out to the end. I now have a wonderful gift for you if you have a CAS calculator. Not all of you do. Sorry if you don't, but because a CAS calculator can actually factor for you if you know how to use the technology appropriately. Some of you might feel like, oh, this is cheating. I don't actually have to do math. I don't feel that way. I feel like it's you knowing how to use a mathematical tool. Now look, if you go on to take AP Calculus or IB Analysis, there's going to be portions of that course that require you to take exams without a calculator. So it is crucial that you know how to do this on paper as well. But for our course, I'm encouraging any method that you feel comfortable with. So on the CAS calculator, we've turned it on, and on this main screen, we're going to open up a new calculator. We're not going to choose from the scratch pad ever. Don't question me on this. We're going to choose a calculator from down here. You can either mouse down to it or you can press down to get down there. Okay, we're in a calculator now. Marvelous. We're now going to press menu. All the good stuff in this calculator happens when we press menu. On this next screen, there's a whole bunch of words here. Some of them you probably don't even know what they mean. That's okay. What does it feel like we were doing today? Hopefully your gut is saying either number or algebra. And guess what? In this case, they actually both work because the third option under number is factor. And the second option under algebra is factor. And they both do the exact same thing. Check this out. Let's factor something easy. Let's do x squared. Okay, the X button is down here, and then to square something, the quick way is just to press this button right here next to the 4. Okay, so X squared, let's do minus 16. This is a shortcut. This is in the form a squared minus b squared. My answer should be x plus 4 times x minus 4. I press enter, and there it is. I can type in that problem we were just working on a minute ago, press enter, there it is. It can be a little fickle when we're dealing with multiple variables. So we should have x times 3 plus y. But if I press enter, it just repeats the same expression again. We can easily fix this. By the way, shortcut, if you scroll up and then highlight the thing that you typed in earlier and then press enter, it pastes it for you, so you don't need to retype things. Huge time saver. The issue here is we need to put a multiplication symbol in between the x and the y. I know that xy means x times y. You know probably that xy means x times y. But the calculator actually thinks that xy is a new variable all by itself, xy. So we need to separate it for the calculator, and now it'll factor it just fine. So good for you if you've got a CAS calculator. This will probably not be the only time this year that I blow your mind with how powerful this device is. I'm still probably going to ask you to do some of these by hand in class just to make sure you kind of get the swing of how this stuff works. But feel free to use your calculator on any class assessments unless I tell you otherwise. I'm getting pretty tired of talking at this point, so thank you very much for watching, and I hope you learned something. Hope you enjoyed. Catch you next time.